Hi, my name is Kamenski and I work at National Instruments. And today I would like to talk to you about the project that I built with myRIO and LabVIEW. I'd like to present to you myRIO Aquaponics. Now, for those of you who are not familiar with aquaponics, let me give you a brief summary. Aquaponics, it's a food production system that farms plants and fish in a mutually beneficial cycle. Now let me explain to you how this works. What happens is the fish eat food and generate waste. As a result, the water infused with the fish waste is pumped from the fish tank into the grow bed, where special nitrogen-fixing bacteria convert ammonia and nitrates from the fish into nitrates, which are then used as nutrients by the plants. The bacteria clean the water from the waste, and clean water is drained back from the grow bed to the fish tank, where the cycle starts again. Now this is all takes place in what we call aquaponic nitrogen cycle, and it continues indefinitely, as long as the aquaponic system is running. Now, a typical aquaponic system, once it's been sized for a particular size, most of the system parameters, such as the grow bed flood level and the timing of the flood and drain states, can be easily changed or modified by the user. Now, myRIO Aquaponics provides the user with that control. With myRIO Aquaponics, the user can take a stock aquaponic system and turn it into a flexible, electronically controlled dynamic system where the user can tune several key system parameters to maximize plant and fish harvest. Now let's go over the major components of the aquaponic system that I have here. First, we have the grow bed that contains plants. I also use clay pebbles as a medium for the plants. In addition, I have a bell siphon that is responsible for draining the water from the grow bed back to the fish tank. I also have a standpipe that accommodates my ultrasonic sensor that measures the water level in the grow bed. Now here I have several plants, such as the hot peppers and bell peppers, and also some basil. Now in addition to the grow bed, we have the fish tank that contains fish. I currently use goldfish. However, you can use tilapia or catfish in your aquaponic setup. In addition to the fish tank is wired with various instrumentation. I have here the ultrasonic sensor to measure the water level in the fish tank. Then I have my pH probe to measure the acidity level in the fish tank. I also have my heater to heat up the water in the fish tank if necessary, and a pump to pump the water from the fish tank into the grow bed. In addition, I have a temperature probe right there, as you can see, that monitors the temperature in the fish tank. Finally, I have a flow meter that monitors the flow rate of the water from the fish tank into the grow bed. Now that you're familiar with the major components of myRIO Aquaponics, let's look at myRIO Aquaponics circuit. Now, myRIO Aquaponics circuit takes all the outputs from the sensors of the aquaponics setup and connects them to the inputs of myRIO. Let's take a close look at those connections. First, we have the BNC connector that connects pH probe to the analog input on myRIO. Next, we have two water level sensors, one for the fish tank and the other one for the grow bed, that are connected to the digital inputs on myRIO. In addition, we have a temperature sensor and a flow rate sensor that are also connected to digital inputs on myRIO controller. Finally, we have a solid-state relay board that takes digital control signals from the myRIO controller and regulates the operation of the pump, heater, and add water controls. Now that you're familiar with the myRIO Aquaponic circuit, let's take a closer look at LabVIEW front panel. Now on the front panel of myRIO Aquaponics VI, we can see various indicators and user-defined controls. The indicators are linked to sensors, and all the sensors run continuously and monitor the current state of the aquaponics system. Let's take a closer look at some of the indicators that we have on the lab front panel. First, we have the current fish tank and grow bed water level indicators. As the grow bed gets flooded and drained, the water levels in the grow bed and fish tank change accordingly. Next, we have temperature and pH level indicators for the fish tank. They monitor the temperature and the pH levels in the fish tank. In addition, we have several timing indicators that display the elapsed time for various system states. Finally, we have a flow rate indicator that monitors the flow rate of the water pumped from the fish tank to the grow bed. We also have several status indicators on the front panel that display the current states of the system. We have 3 LEDs that display the current status of the pump, heater, and the low water control. Each of these LEDs is directly linked to a digitally controlled relay in the myRIO Aquaponics circuit. Finally, we have several text status indicators that display the current states of the fish tank and the grow bed. In addition to indicators, we have several controls that allow the user to tune the aquaponics system for the desired performance. On the grow bed side, the user can set the grow bed flood level that controls the flood level in the grow bed, the flood level time that controls the amount of time the grow bed stays at a particular flood level, and the pump off time that controls the amount of time the pump is off after the drain state. Now, as the system runs, these user controls are continuously monitored within the code, and the user can change the system parameters on the fly. Now that you're familiar with the front panel controls and indicators, let's observe one cycle of the system and play around with some of the system parameters. Currently, the system is in the flood state. That means that the water is being pumped from the fish tank to the grow bed. Now, the current grow bed flood level is set to 6.5 inch. Let's change that to 5 inches. And once the water level in the grow bed reaches 5 inches, it will stop and will enter the post-flood state. In addition, you can see the pH is being continuously monitored, and the temperature in the fish tank is 85.5 degrees. Let's play around with the temperature and set the threshold higher, and we can see that the temperature, the heater is going to turn on. Now we set the temperature to threshold to 88, and the heater is on, and it will stay on until the temperature reaches 88 degrees. In the meantime, our grow bed water level continues to rise, and once it reaches 5 inches, we're going to enter the post-flood state. As you can see, currently we're in the post-flood state, and it will stay there until the flood level timer has elapsed. The flood level timer is currently set to 15 seconds. Once 15 seconds has elapsed, we're entering the drain state, where the water will be pumped into the grow bed until the bell siphon effect takes place, and the grow bed will be fully drained of the water. Now, in summary, you can see that myRIO Aquaponics allows the user to monitor and control several key parameters of aquaponic systems, such as temperature, pH level, water levels in the grow bed and the fish tank, and also tune different timing parameters of the flood and drain cycle. As you can see with myRIO LabVIEW, I was able to create a flexible aquaponics control system that allows me to monitor the health of my aquaponics setup and also tune various system parameters to achieve maximum plant growth and balanced power consumption. Thank you very much for watching, and I strongly encourage you to build your own aquaponic system.